So in this lesson, we're going to identify proportional equations. I'm basically going to give you an equation, you're going to tell me if it's proportional, and then you're going to create different representations. If you notice, most of your equations look like this, where it's only multiplication, no addition, no subtraction, division's weird, but no addition, no subtraction, nothing like that. Only multiplication, and remember the number that we multiply by is called the constant of variation. The reason they don't usually show it with the C is because then it sort of can look like a 0 or whatever, but that K is constant of constant. It's called two things, constant variation, but for our class we'll call it the constant of proportionality. Constant of proportionality, I guess that will work, right? Okay. So let's look at these. This is y, or something equals something times something. Something equals something times something, right? That's multiplication. So this one is proportional. This one is subtraction, so it's not proportional. I'm just gonna, I'll write it like that, not proportional. I was gonna mark it out, but it's easier. This one has multiplication, but then it has addition, so this is not proportional. We're looking for only multiplication. Right here, multiplication and subtraction, so it's not proportional. This is multiplication, right? Something equals something times something. This is proportional. This is multiplication and only multiplication. This is a fraction, but it's still times, so it's proportional. And you may not see it, but remember, there's a one, like an invisible one that you don't see. So this is proportional. And this one is 2. It's just b times h. And then x times -3, that's still just multiplication, proportional. So on this page, we will be given an equation, and we will decide if it's proportional, and if it is, then we will represent it. So our equation is y equals 2x. This is proportional because it's just multiplication here. The variable we care about is going to be this y right here. So our dependent variable is y. And our independent variable is x. Like we decided, it's just multiplication, so it's proportional. So y, our dependent variable, is proportional to x. So y is proportional to x. It doesn't give us any values or anything, so let's just go 0, 1, 2, 3. And our constant of proportionality, the number that we're multiplying by, is 2. So k is 2. So times 2 is 0, times 2 is 2, times 2 is 4, and times 2 is 6. So y is our dependent, x is our independent. 0, 1, 2, 3, 1, 2, 3. Okay, so 0, 0. And this goes with our other lessons. We have to go through 0, 0, right? 1, 2, 1, 2, 2, 4, 3, 6. And it keeps going. If you notice the pattern, then you can just draw some extra ones in. That's good enough. Let's look at the next one. So in this one, a equals 1/2 t. So this is proportional because it's just multiplication. T is the number of tomatoes, a is the number of apples. So we care about this a for apples, the number of apples. So that's our dependent. Since I already have it labeled there, I'm just gonna abbreviate a little bit here. Number of A. And T will be our independent, so number of tomatoes. And so we know that this is our dependent, so the number of apples is proportional. Remember to write it all out. Proportional to the number of, let's just write that whole thing, of tomatoes. Oh, but this time we have a horizontal table. So remember, the one we care about, our dependent variable, will go second. So A is right here, and T is right here. So it doesn't give us any values for T, so 0, 1, 2, 3. So times half, or 0.5. I'm just gonna do it like that. So I'm gonna take this away. I'm gonna say that our constant of proportionality, let's always write it out, is going to be half. And if it's in decimal, if it's in fraction, it will be useful to write it in decimal. So, actually, I'm not going to draw that arrow. I'm just going to times 0.5 times 0.5 times 0.5 times 0.5. 0 times anything is 0. 1 times 0.5 is 0.5. 2 times 0.5 is 1. 3 times 0.5 is 1.5. And then, because there's a lot of decimals here, I'm just going to throw in another one right here. 4 times 0.5 is 2. So 0, 1, 2, 0, 1, 2. Our dependent variable is apples, number of apples, and our independent variable is the number of tomatoes. So 0, 0. Good so far, makes sense so far. Well, I guess I'll show you how to graph these. So 1 and then 0.5. 2 and then 1. 2 and then 1. I'm going to skip this one. I'm just going to go to 4, 2. 4, 1, 2, 3, 4, 2. I just wanted to show you the decimal one. If you just want to graph the decimal, that's fine. I had to put the 4 there so that I could get a nice whole number. You know what, I'll just write this one in. I don't want to confuse anybody. So 3, 1.5, 3, 1.5. There we go. And you can tell it kind of goes like that. All right, cool. Lastly, we have this equation, C equals 4 plus 0.5 H. C is cost, H is number of hours, but there's addition, so this is not proportional. So we're just going to not proportional and then move on. A couple of things before we're done. Don't forget to write your K, your constant of proportionality. Don't forget to write your constant of proportionality, the number you're multiplying by. You now have it here, and I have it here. Also, don't forget, if it's a fraction, then go ahead and write it as a decimal so that I know that what you're multiplying by here. And that is it. Thank you.